All right. Good evening, everybody. I believe you can hear me, correct? All right, guys. So, without wasting so much of time, let's just get started immediately. Okay. All right. So, we're just going to be continuing with what we started yesterday. So, see how much we can get to do today, and just round off, right? By next week, like I promised, we're going to start with the the main part, which is the designing, right? So once we get through all the theoretical aspects, right, um, we just have to deal with the main designing parts. Okay. So yeah, I'm loading my slide right now, and I'm just going to quickly start from where we stopped last week. All right. My screen is visible now. All right, please confirm you can see my screen. Confirm my screen is visible. All right. So yeah. So right here, I'm just going to be doing a recap of what we started with last time. Right here, I have two solar panels. Right. Call this panel one, and then call this panel two. Right. Call this panel two. Now, for the for the first panel, connect. We're trying to connect these two panels. All right, together. That's what we're trying to do. Trying to connect the two panels together. Okay. So we're trying to connect the two panels together, and we can connect the two panels together in two ways, either series or parallel, right? Either series or parallel. So if you want to connect in series, I said you have to you have to pick one of the terminals of the first panel and connect it to an opposite terminal, all right, which means you pick one terminal, all right, and connect it with the other terminal, right? This way, you have successfully connected these panels, all right, in series, such that this becomes your what? The positive output, all right, the positive output, and this becomes what? The negative, all right. Let's say 5 amps, all right, 5 amps. And the second panel is also rated 20 volts, all right, 5 amps also, 5 amps also, all right. By the time you connect these two panels together in series, I told us that whenever you connect in series, the voltages increase, right? So the 20 volt is going to add up to the 20 volt of the second panel, and you're going to have the total capacity of these two panels connected together to be what? 40 volts, all right? In series, their current does not add, all right? The current does not add. So they are going to retain the same 5 amps of current. All right. After you connect these two panels together in series, they are going to retain 5 amps of current, but the voltage increases. All right. So if we decide to now connect, say we don't want to connect in series, we want to connect. Okay, yeah, this is it now. So I lost my slide for a while. I had to go look for it again. Let me share my screen now. Yeah, this is my slide. All right, so this is literally where we stopped yesterday's night, and yeah, this is where we stopped yesterday night. So I just tried to show us what it means to connect panels in series and parallel and all of that. We're still going to go into the theories when we go to when we get to sizing the inverter and all of that. So, but for now, I just covered the basics of connecting solars in series and solar panel in series and parallel. So let's just quickly move on and ensure we round off with this slide, and then as from next week we'll go in depthly into everything that we have talked about all the way from Monday. All right. Okay, so let's talk about the solar charge controller now. Now that we have gotten ourselves familiar with panels, all right, we can talk about the charge controller. Now, the charge controller is that device that helps you regulate, all right, take note, regulate and also maintain the voltage for the charging voltage for your battery, all right. So key function is that they act as the system's brain, all right, between solar arrays and battery banks, all right, ensuring safe and efficient operation, prevent battery from overcharge to extend battery life and maintain safety, protect battery from deep discharge using low voltage um, disconnect feature, all right. So um, the most important feature of the charge controller is that it helps you stabilizes and also regulates the voltage, the charging voltage for your battery. All right. What that simply means is that your the power or the electricity that is being generated from the solar panel is not the same at every point in time. Nothing is showing what's going on. Is everybody experiencing that? You are not seeing anything. Please confirm if you can see my screen. Okay, it's okay now. All right, cool. So I was saying that the main reason why you use the charge controller is because the electricity that is being generated on the panel every point in time is not the same all through the day. As a matter of fact, it's not the same all the time. All right. So at some point, the panel generates, let's say, for instance, if it's a 40-volt panel, it generates about 35 volts. At another time, it generates 28. At another time, it generates 40. At another time, it generates 38, and so on. So, it fluctuates like that all through the day. Why? Because the intensity of the sun blasting the solar panel is not the same all the time. Sometimes the sun is up, very, very intense, and sometimes the intensity of the sun is down. Sometimes it's just on the average. All right. So it fluctuates like that all through the day. So, but you can't have that kind of fluctuation on your battery. It's going to damage the battery. The battery requires a constant amount of pressure, all right, to keep it steadily charged. I mean, to keep it charging, all right, and at the same time, the pressure is not so much as to destroy the battery. All right. So the battery needs that stabilized, pressure or voltage across it at every point in time. So with the help of the charge controller, it doesn't matter how much, whether the sun is up or the sun is average or the intensity is, the charge controller ensures that it stabilizes the output voltage that is being delivered to the battery at every point in time. Right? At every point in time, it ensures that it stabilizes the voltage, all right, that goes to the battery every point in time. All right, so even though the voltage is 28 volts, all right, if what your battery needs is around, let's say, 55 volts, all right, the charge controller does the job of converting that 28 volts to 55 volts that your battery requires. So it does that every time. So even when your charge controller is receiving above 55 volts, all right, let's say it's receiving 80 volts or 200 or 500 volts, the charge controller also reduces it back to around 56 volts that your battery needs to charge. All right. So that is the primary job of the charge controller, to stabilize the voltage, the charging voltage for the battery. All right. It also monitors the charging of the battery. All right. It also ensures that because the battery has charging stages, the battery charges in stages. All right. So the current and the voltage that the battery needs for those stages are not the same. The charge controller also ensures it maintains it gives it that particular voltage or current that it requires for a particular stage. And when it moves on to the next stage, the charge controller ensures that it changes the voltage or the current on the battery. At every point in time, every stage of the battery, the charge controller ensures that it gives it the correct voltage or current that it needs. That is the major work of the charge controller. All right. So let's move on. Let's move on. So yeah, it acts as a brain between the solar array and the battery, all right, ensuring safe and efficient operation. It prevents the battery from overcharge, all right. So if at any point your battery is full, the charge is the job of the charge controller to stop the battery from charging, all right, because if your battery is full and it keeps charging, the pressure on the battery is going to be much, and then it can burst, all right. It can dissipate, it can create a lot of heat for lithium ion or lipo batteries. It creates heat, and then it can even damage the battery or the BMS. All right. So that makes sense. Now, the charge controller prevents it from what? From overcharging. It also protects the battery from very low discharge. So if you are using your battery, for instance, that is connected to a charge controller, the charge controller ensures that the battery, all right, is not discharged deeply. What that means is that if the low voltage cutoff of the battery by default is supposed to be around 10 volts for a 12-volt battery, once it gets to 10 volts, the charge controller ensures that it no longer supplies power to the inverter, so that the inverter can draw from it. All right. So the only if you run your um, um, if you run your how would I say now? If you run your inverter directly to the battery, then the charge controller does not have. But the charge controller has a low voltage disconnect. Anytime the battery is low critically, it disconnects it. Right? It disconnects it. And then it also manages I've talked about this, manage the charging, all right, with tailored algorithm for optimal battery health and performance. All right. Supports 12 volts, 24, 48 volt system, all right, to match different solar. So one thing about the charge controller is that it's designed for 12 volts, 24 volts, and 48 volts. So some charge controller can undo the three, all right, or even if it's 96 volts, all right. They're designed so some charge controller are smart. By the time you you connect your battery to charge controller, the charge controller can detect and read the amount of voltage of the battery and let you know that it lets the charge controller know the value of the voltage of the charge controller. All right, so it adjusts its parameters by itself to suit that battery. There are also some batteries that are smart enough to detect the type of chemistry of your battery. All right, so yes, most charge controller can do that. All right, so yeah, and then they also have they specify maximum input voltage that must never be exceeded to avoid damage. So yeah, your charge controller has its limits. It has its maximum amount of voltage that you can accommodate, you can undo. So if you go beyond that amount, you are going to damage the charge controller. Right? It's rated in voltage and also in current. So you don't want to exceed either voltage or current. So whatever amount of solar panel you are connected to the charge controller, you have to ensure that 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 charge controller can handle the amount of panel that you want to run to it. You have to ensure that. Very important. We are going to see how to do all of that when we go to the sizing and all of that. All right. So also limits max current, defining the maximum solar power and all of that. Yeah, I've talked about that. And then accounts for controller self consumption, power to optimize system efficiency and all of that. So you can actually record the power consumption. You can actually see what you're consuming of the panel, and you can maybe use that data to do whatever you want to do with it. All right, let's move on. So we have types of charge controllers, right? Two of them majorly. We have the PWM, which is the pulse width modulation controllers, and we also have the MPPT, which is the maximum power point tracking controllers, right? So both the PWM or the MPPT have the multi-stage charging modes, right? They have the multi-stage charging mode. I'm going to explain that briefly later. So the PM and the PWM controllers are very simple, cost-effective solution for small systems, small systems. Panel voltage closely matches battery voltage, less efficient compared to MPPT. Now, the PWM charge controllers are also good, right? If you're dealing with a very small, solar system or PV systems, you can actually use, PWM. For instance, let's say your battery is just, two tubular batteries, or maybe about 2 kilowatts, system, very small system. You understand? You could actually still use a PWM charge controller. All right. The only downside to them is that they have less efficient. They are less efficient compared to the MPPT, right? So if the MPPT gives you around 90% efficiency, the PWM can give you around 70 to 75% efficiency, which is also good, right? Depending on what you're looking at. Okay. So and that's just it. The maximum power point tracking, right, controller is more advanced, right? Efficient technology increases output up to 30%. All right. So tracks panel maximum power point for optimal charging and convert excess voltage to increase the current charging. Actually, all charge controllers are designed to do this. All right. What that means is that if the battery, all right, your battery, for instance, that you want to charge is 12 volts, and the panel that you run to your charge controller is around 30 volts. If that 30 volts gets to your battery, it's going to damage it. All right. So what the charge controller does is to take that 30 volts, all right, trims it down to 14.4 volts, which is the charging voltage for a 12-volt battery. It takes that 30 volts, breaks it down or trims it down to 14.8 or 14.4 volts that the 12-volt battery needs to charge. All right, the charging current for a 12-volt battery is around 14.8 volts. All right, so it takes that 30 volts, converts it to 14.8. So question is, what does it do with the remaining 16.6 or 16.2? It converts the remaining to current. All right, and how does that work? It uses the power formula. All right, such that at every point in time, the power is going to be the same, whether you increase, because if you increase the voltage, right, the current should increase to match up with the current. All right, so if it reduces the voltage, it's increasing the current so that the power can always be the same. All right, if it reduces the current, it's increasing the voltage so that the power matches up at every point in time. All right, if that makes sense to us. Are we following? Please let me know if you're following. Let me know if you're following. Hello, sir. I have a question about to use solar panel. How can you connect? I don't quite get your question. Dahiru Abdullahi. I really don't get used panel. Pretty much the same way you connect your new panels is the same way you connect used panels actually. Right? Yeah, it's pretty much the same way you connect them. Right? I mean, there's no difference, even though they are used. All right. So please let me know we're following. Are we following? Are we following? Following. Are you guys with me? Okay. Okay. Thank you, Samuel. Okay. Sorry, guys. All right. So let's continue. Let's continue. Yeah. I hope we're gaining. I hope that we're getting useful information here. I hope we're gaining value. I hope it's worth our time. All right. So this is. Oh, I think I missed out on something. Yeah. Multi-stage charging modes, right? Of charge controllers, right? And this also applies to batteries. All right. The way your battery charges, right? This also applies to the way your battery charges. So um, when your battery is low, all right, and you want to charge it, this also applies to your phone batteries, any kind of battery, right? Pretty much any kind of battery. So when the battery is low and you apply, you supply it power for charging, all right, the first stage of charging that the battery undergoes is what we call the bulk stage, all right, or bulk charging stage, all right. At that stage, the the battery wants to get as much voltage, right, as needed. All right. It wants to get as much voltage. As a matter of fact, there is increase in voltage at a constant current. Right. It needs more pressure because the battery is low, right, at that time. All right. But during absorption stage, but let me there's a material I would want us to um where's this? During absorption stage, right, the battery is almost full, right? I mean, the battery is almost full. So it does not require so much of pressure, all right, like the first stage. So this point, the voltage begins to drop gradually, all right? The voltage begins to drop gradually. I mean, the charging voltage now, all right? And just to maintain, some level of voltage over the battery to keep it charging at a minimal level, all right? Because now the battery is settling, right? And it doesn't require so much pressure again because the battery is even almost full already, all right? So that is the absorption stage, right? And at this stage, all right, it reaches what we call a regulation voltage, all right? And this stage, the voltage is held constant. Remember, the first stage, the voltage keeps increasing because it needs a lot of pressure to kickstart charging the battery, all right? But now at this absorption stage, right, the voltage is held at a constant value, right? And the reason is that voltage, I told us, voltage is like pressure, right? It's like energy, potential energy, like pressure, right? So if you keep pumping in voltage at absorption stage, there's every tendency that your battery overheats, right? And overgases, right? If you are using tubular battery, or it's going to be gassing out a lot, right? If you see that your battery is gassing out a lot, it's probably due to the fact that maybe the charger you're using does not have all these stages, all right? But if your controller does that, or your charger has that, at absorption stage, there's a need for the voltage to be constant, right? So as to avoid overheating and that kind of stuff, right? So at this point, the current also will taper down to a safe level, right? It will taper down to a safe level. It's not, like the way the current is being pumped into it in the LS stage, right? The current is being pumped into it in the LS stage to charge the current and all, I mean, the battery and all of that. But at this point, the current is reduced, all right? Because the battery is almost getting charged, right? I mean, it applies to your phone battery also. As your phone battery is getting to around 85, 90, the charging current reduces. If you want to see these things, right, if you can get a charger, right, that can show you the charging current, you're going to find out that when the battery is almost full, the current is almost at zero. So I think there's this solar charging charger that they used to sell. if you can get that, it's not important, but just for us to see how the current reduces as the battery is getting filled. All right. So that's the absorption stage and all of that, right? And at this stage, the battery is going to be charged fully, right? It's going to be charged fully. And then there's another point, another stage that is called the float stage. All right, the float stage, which so at this point your battery is fully charged. The float stage basically just preserves the full charge without overcharging the battery, right? So once the battery is fully charged, it cuts off and it just preserves that, maintains the voltage, the full voltage of the battery. It just maintains it, right? That's the float stage and all of that. So let's quickly move on. I hope we'll be able to finish this slide. Okay. Oh, what page are we on? 10. All right. So maybe I'll just rush a little bit. It's 9:12 already. So we also have equalization, although this is not, this doesn't include all charge controllers or all charger. Equalization is always an optional kind of stage. All right. So it controls the overcharge for flooded lead acid batteries, right? That raises voltage briefly to break sulfation and balances cell voltage exceeding the battery life. All right. So this usually is in water batteries, flooded batteries and all of that. So it controls the overcharge, right? And it raises the voltage briefly to no. So sulfation means when you're charging your battery and the battery is full, right? And you keep charging it. If there's no cutoff, all right, to stop the battery from charging, it enters into sulfation that can begin to cause a lot of gases to erupt from the battery and all of that. So what the equalization does is to just raise the voltage briefly, all right, and break the sulfation and then balances all the cell voltages. So the auto equalization checks the cell voltage. What that means is that in your battery, for instance, your tubular battery, is a lot of cells that are arranged inside that tubular battery and are connected together to form a whole battery. Right? The singular unit of battery is called cell. Right? So those cells are arranged together inside that tubular battery or gel batteries to form a whole battery. Right? So what the auto equalization state does is to check the battery voltage of each of those, the cell voltage of each of those cells and ensure that they are balanced. All right, so that's what it's on. So that will help you extend battery life, because if they are not balanced, there's every tendency that there's, it gets heated up. All right, so one cell is going to be charging the other cell, because you have to understand that current flows from a higher potential to a lower potential because of the fact that they are connected together. If one cell is higher than the other, current will flow to the lower cell, and that will damage both batteries. Both cells. Right, so that's why the auto equalization, is very important. Now, some of the things that you have to keep in check with is that you never use auto equalization on AGM, gel, or lithium ion battery, as it causes permanent damage. All right, and that's why in lithium ion battery we use there's what we call battery balancers. All right, most BMS have that, that balances the cell voltages. All right, because of the fact that in lithium batteries you are connecting a lot of batteries together, right? Even that big 20 kilowatts battery, lithium ion battery, is, if you open it up, you are going to see different cells of battery inside. Those are the ones that are connected together. It's not necessarily just one battery, like, no, there are cells connected together inside it and all of that. All right. You also have to ensure load terminals allows direct powering of DC appliances for the controllers, streamline for low voltage disconnect protection, automatic cuts power to the load when the battery is low. Right. So your device or your inverter should have all of those features. It does disconnect. It puts off the inverter whenever the battery is critically low. Right. To prevent critical discharge, and then discharge the battery critically, gets damaged over time. Right. So low voltage disconnect protects the battery health, ensuring load only draws safe power, preserving overall longevity of the battery. All right. So battery types and solar applications. So we have the non-rechargeable batteries, which are the ones you use for your remote, your watch and all of that. And then we have the secondary, which are the rechargeable battery, which are good for energy storage. All right. We have this SLI battery. I've forgotten the full meaning of SLI battery, but I think it's Salt Lake something. battery, right, deliver high current in a short burst, but have poor deep discharge tolerance, making them unsuitable for solar systems, right? So let me see if I can get. I think I have one such in mind. I don't want to waste. I don't want to waste time looking for this stuff, right? But there is salt lake something something. Yeah, I've seen it. Okay, salt water batteries. Salt water battery. All right. So they are not really suitable for solar system, because in solar system energy needs to be stored and be discharged consistently over a long period of time. The SLI batteries, they can give you a high current burst in short period, but they don't have that stamina to deliver power to you over a long period of time, right? So you also have the deep cycle battery, which most of us are familiar with. Deep cycle batteries provide long-term current current and withstand repeated charging cycle and ideal for solar system, right? So the lead acid battery is a typical battery you're going to get in the market, right? Lead acid battery is a typical battery. All these ones are going to get in the market, right? It can be sealed, it can be, so basically lead acid are divided into flooded lead acid and the gel batteries. The gel batteries are the plasma batteries, right? You guys call them dry cell, all right? Especially solar installers, they call them dry cells, all right? So, but both are under lead acid battery. Either the FLA, which is the tubular battery, the ones that contain water, or the sealed, which is the gel batteries, right? They are both lead acid um, batteries, right? So yeah, small. So you have the FLA, which requires maintenance, ventilation, and most affordable. So the FLA are your typical um, tubular battery. All right, tubular battery. So this is how a typical tubular battery looks like. All right, this is how a typical tubular battery looks like. Right, this is how a typical lead acid battery. I mean tubular battery looks like for some of us that might not know. All right, and then you also have now the tubular battery. Okay, let me just continue. Let me just continue. You also have the AGM, right, which is the absorbent glass mats, sealed, maintenance free, higher cost, reliable for varied conditions, right? So those are your. They look like gel batteries also, right? But they are not really gel batteries. They're not, pretty much look alike. Let's check them out. Right. So yeah, they look more like your gel batteries, but they're not really gel batteries. Okay, so there are also dry cells. Also, you can see inside of it. Right. So those are um, AGM battery. So you also have your sealed, I mean, gel batteries, which are also sealed, maintenance free. All right, they are sealed, maintenance free, suited for deep discharges, but expensive also. Right. You also have the lithium ion or LiFePO. Right. These ones are expensive, delivers up to 80% depth of discharge, longer life, lightweight, minimal maintenance, and so on. Now, the FLA, the AGM, the gel batteries can only give you around 50% efficiency, right? Which means that if you go buy a 2 kilowatt gel batteries in the market, right? What you are expected to get ideally from that 2 kilowatt gel battery is 1 kilowatt, because it can only deliver to you 50% of its capacity, right? So if you're doing calculation for your customer and you are putting accounting to say you went and buy 2 kilowatts, so your say for instance your your client needs about 2 kilowatt battery, and you just go to buy you just go directly to buy 2 kilowatt gel battery. the way your client will call you back to come and fix the issue that you have caused, because that client will not be able to get 2 kilowatts from that battery. You only get around 1 kilowatt because it can only give you 50% efficiency, right? But for LiPo, right, or lithium ion, they deliver up to 80 to 100% efficiency, all right? Which means that if you buy a 2 kilowatt LiPo battery, you can get up to 1.8 kilowatts from it, which is pretty, okay. You can even get the 2 kilowatts depending on the type of battery and all of that, right? So for LiPo, and LiPo, out of all the batteries, LiPo has the highest depth of discharge. Longer life, right? Also, um, a more, it still boils down to longer life, right? It has a higher life cycle, right? Or battery cycle, okay? Yeah. So for instance, if you go to buy a Felicity lithium battery, they usually have, let's say for instance, the 10 kilowatts usually comes with 6,000 cycle, all right? And what a 6,000 cycle, all right, from the battery means is that it's you can charge and discharge it 6,000 times before it begins to derate. That's what the 6,000 cycle. So if you go to buy a battery, you really want to check out what's the cycle of this battery. All right. Some only have 500, which means that you can only use it roughly 1.5 years. That's if you discharge and charge it every day. So within 1.5 years, the battery has started misbehaving. Right. But for LiPo batteries, they have up to 6,000 cycles, which means you can charge and discharge them 6,000 times before they begin to derate. So let's say you charge and discharge every day. 1 year is 365 days, right? 2 years is about 700 plus. 3 years is around 1,000 plus. All right. 4 years. So which means you can actually use LiPo batteries for 10 years. All right. Even more than that before they begin to misbehave. So they are very long lasting and very durable battery and all of that. Okay. So let's continue. So you have the lithium ion batteries, all right, that they are similar to LiPo batteries in terms of the depth of discharge, the longer lifespan, lightweight, and minimal maintenance also. All right. So, but overall, you have to choose the battery based on your budget, all right? Maintenance capacity, performance needed for the solar setup. So basically, if what you're looking at is not really a serious system, let's say like a 1.2 kilowatts, 1.5, 2 kilowatts, even 3 kilowatts sometimes, just want to go with maybe FLA batteries or AGM or gel batteries, right? By the time you're looking into 5 kilowatts, 10 kilowatt, 20 kilowatt system, please go for LiPo batteries for your installation. Go for LiPo batteries. Don't mind the price, it's expensive, but the customer will enjoy it. All right. Also, if you know that the customer is a very clumsy person that cannot do maintenance, don't buy flooded batteries for them, because they're just going to make a mess of it. They won't be able to do maintenance on it, and they're just going to make a mess of it. So choose a kind of battery for them that wouldn't require so much of maintenance from them. Right. I hope you're following. Are we getting it? Are we getting value? Let me just rush the rest. Our time is, we should round off already. All right. So there's what we call SOC and DOD, depth of discharge or state of charge. All right, and you have to understand key spec, nominal voltage, e.g., 12 volt. If 12-volt battery, right, the capacity age, cycle life, and depth of discharge representing the efficiency. Representing the percentage of the capacitor used. Monitoring the specs and the SOC helps optimize the battery use, ensuring longer lifespan. Now, the DOD, which is the depth of discharge, tells you how deep you can discharge this battery. Whenever you see DOD on batteries, they tell you how deep you can safely discharge this battery. Number one, to prevent damaging it, and number two, to give it a longer lifespan. Right? So take note for your AGM gel flooded battery, which is a tubular battery. They have a safe depth of discharge of 50%, right? Don't discharge them beyond their 50% level, okay? Don't discharge them beyond their 50% level. And I'm going to show us a chart that shows the 50% level of some of those batteries, all right? So once you discharge it to 50%, please disconnect and start charging it again if you want your battery to last. But for LiPo lithium-ion batteries, you can discharge them up to 80%, even 90%, all right? Because they are very, quality and durable batteries. Now, the state of charge, all right, shows you the current amount of charge that is on the battery. So every one of you look at your phone right now. What percentage is on it? The percentage on it is showing you the state of charge of the battery. So for instance, now on my phone, right here, I have 29%. It's telling me that the state of charge of my phone battery is 29%, which means I have discharged about what's that? 60 I've discharged about 71% out of it. I've discharged 71% out of it. So the depth of discharge of my phone currently now is 71%. Okay, the state of charge is what? 29%. The depth of discharge is about, and that's why you can use your phone up to 0% before you go and charge it, and you still it's still going to, you can't do that to the flooded battery. It will not work again. You can't even charge it again. It will not work again, right? You can't discharge or where it will not work again. So, but for lithium batteries, they can allow that kind of depth of discharge and so on. Let's move on. Right. So I've explained this already. Battery life is influenced by the cycle of 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 his life. That's cycle life versus depth of discharge, temperature, maintenance, and charging quality. All right. You really have to take note of these things. All right. These are the quality of your battery over time. All right. The depth of discharge should follow, depending on the size of battery that you're using. The depth of discharge should not exceed what is recommended by the manufacturer. Right. So also, don't keep your batteries in places where there's the temperature used to go up. If you keep your batteries in a place where there is heat, you're going to be damaging that battery over time. Batteries don't do well with heat, right? And that's why iPhone batteries don't last. Sorry, iPhone users, I don't mean any. If your iPhone is getting long, all right, you find out that if you have used it for a long time, right, it gets hot, all right. That heat does not go well with your battery. That heat is going to also damage your battery over time, because heat does not go well with battery. So you have to ensure that you keep your battery in a well ventilated area, such that it can receive ventilation, be able to drive heat away from it, and all of that. Also, the charging quality of your battery matters. Don't go and connect one nonsense charger to battery that will not charge it properly. You are going to damage the battery. Also, even your phones, buy quality charger for your phones. Right? Don't say, buy quality charger. Don't go and be using 1 amp to go and be charging your iPhone. All right? Buy quality charger for your phone so that you can preserve the battery life. There are some things that, even if you use an iPhone, there are ways you can take care of your battery. Don't allow your battery to run down to maybe 20% before you start charging it. It's going to damage the battery, over time. So once your battery gets to 20, plug it. You understand? Plug it. That way you're going to be preserving the battery life and all of the over time, right? And yes, take good maintenance of your battery and all of that. So I've talked about it already and all of that. Talked about all of this. Yeah, store in a cool condition, all right. And yeah, if you are not going to use your battery over a long, and that reminds me, I have one battery on site that we have not charged for over, it should be more than 4 months now. I have to find a way to charge those batteries before they get bad. So if you're storing your battery for 3 to 6 months, right, you have to ensure that at intermittent time you go charge those batteries, because they can get damaged like that if you leave them. but I have to go this weekend. I'll go there this weekend and find a way to charge those batteries. I'll do that. Right? So you have to, if you are keeping your battery for, and that's if you are not using it, you understand, you just keep it in one corner. Ensure that within the space of 3 to 6 months, ensure you charge those batteries. Even if they are still full, still put charger on them. All right. That way you are going to be refreshing the battery, and they are not just going to damage and all of that. Okay. So please, also, battery self-discharge. All right. And that's why you have to always, keep up with their charging, the self-discharge, you understand? 5 to 15% monthly, and all of that. Okay. So now, don't ever mismatch battery. Right? What that means is that at every point in time, don't try to connect tubular battery to a gel battery and say you want to add battery together. You want to increase it. No, don't do it. If you want to add batteries to battery, right, ensure that number one, they are of the same rating. So if it's a 12-volt battery, ensure that the battery you want to connect to it is also a 12-volt battery. They must also be of the same current. If it's a 220 Ah battery, for instance, the battery you want to add to it also have to be 220 Ah. So you have to get a 12-volt battery, 220 Ah. The current and the voltage has to be the same. Another thing you have to ensure is the chemistry of the battery. If the battery is an FLA and you want to connect another battery to it, ensure the battery you're connecting to it is also an FLA battery. All right? Ensure the battery you want to connect is also what? An FLA battery. If you're connecting lithium-ion batteries together, ensure all the batteries are lithium-ion that you want to connect together. Right? Also, if you are connecting a gel battery and you want to add batteries to a gel battery, ensure that the battery you're adding is also a gel battery. Don't mix match the battery chemistry, the voltage, the current. Ensure that whatever up to your panels, okay? If you're connecting solar panels together, ensure that of the same power rating, the same voltage rating, the same current rating. All right. There's a way you can, connect different ratings of panels together, but we're going to see it later during the course, right? But fundamentally, don't connect any battery and any panels of battery that are not of the same rating. Very important, please. Very important. This can cause fire. It really can cause fire. And even if you have a battery that you want to add to it, and you have been using that battery for, like, let's say 3 to 6 months, please don't connect another battery to it. All right. For 3 months, 4 months, you can still risk it. But once it gets to 6 months, don't connect any other battery. Say, okay, let's just buy this battery now. After 6 months, we're going to add another. No, don't do that. The reason is that the battery degrades over time, and even with a slight difference of 1 volt in the battery, it can cause a lot of it, and it's going to damage the 2 batteries if it does not cause fire. So please, once you notice that 1 battery is getting old already, don't add new batteries to old battery. Don't do that. Right? So be very careful and all of that. Don't mismatch batteries for safe, reliable power systems. Right? So you can actually risk batteries of different brands. What you have to ensure is that they're of the same chemistry, the same rating, and all of that. They can be, say for instance, Star Plus tubular battery. You can actually connect it to luminous tubular battery. Right? But you have to ensure that they are 12 volts and the same current. All right. The reason why I say you can risk it is because as much as possible, ensure to use the same brands of battery, right? As much as possible, right? But let's say you are in a very bare position, right? You can risk it, right? I've done it before, and there's no issue. Like, it works even up to now. So you understand, right? We have to ensure that both batteries are new, right? Both batteries are of the same chemistry, rating, and so on, right? All right. So I think we should stop here. It's just going to take another time. I really don't want us to use more than 1 hour. I hope we learned. I hope it makes sense. So does the direct sunlight affect lifespan? No, 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 no. Direct sunlight, uh, uh, direct sunlight does not affect your battery. Your battery does not receive direct sunlight, right? What your battery receives is the the power that is coming from the charge controller, right? Direct sunlight does not. So, and that's why the panel has to be connected to a charge controller, right? So as to regulate the the um, the fluctuation of the sunlight during the day, right? And ensures that the battery voltage is consistent, right, over the battery, right? If that makes sense, all right? So, yeah, don't have time to start talking about inverter. So I think we'll pick it from there. I thought we were going to finish up with this, but I don't want to go into inverter now. All right. So yeah, we'll talk about inverter next week, and then we then we then start with sizing the inverter itself. All right. We start with sizing the inverter itself and all of that. All right. So what about the heat from the sun? Yeah, we talked about that when we we're discussing the solar panel. The heat from the sun, the heat from the sun affects the generation of electricity by the solar panel. I mean, yeah, by the solar panel, right? So at a very intense temperature, right, the solar panel tends to reduce in its performance. That's how much it converts the radiation coming from the sun into electricity, right? So yeah, it does affect it, but it's not really significant on in a very small system, right? But when you're dealing with a large system, it's it can be very significant. So you have to put into consideration how much of loss you can have when there is intense heat, all right, especially in arid areas or desert areas where you have a lot of high temperature there and all of that kind of stuff. So yeah, it affects, but it doesn't directly affect the battery. No, there won't be class this weekend though. I mean, guys, let me rest, I beg. There won't be class this weekend. We're going to continue on Monday, right? We're going to continue on Monday. So I have a lot of places to be tomorrow and even on Sunday. So let me just have my time, please. Thank you. So yeah, the sun does not directly affect the battery, right? It only affects the charging of the battery, because the solar panel, is generating power from the sun, right? So whatever is happening to the sun is happening to the panel, and so on. I hope that makes sense. I hope we learned. I hope we gained from the class. I hope it was worth our time. How has this week been so far? I hope it makes sense. Guys, I hope we gained. I really want to get our feedback. Was it worth our time? All right. All right. Thank you. Uh, all right. So we call it a night from here, and we'll meet again on Monday by God's grace. All right. So we start with the inverter and the sizing of the inverter and all of that. So yeah, thank you so much, guys. I'm grateful for taking out time to attend this training. All right, and yeah, thank you, guys. So we meet again next week by God's grace. You have a nice weekend, and please try as much as possible to maybe do more research on everything you have learned so far. And yeah, I'm actually leaving the link open, right? So we can also go over. I wanted to keep it private before, but I just felt, let me leave it open for people who don't really have time during the week. So maybe they can, quickly catch up during the weekend and all of that. All right. Thank you guys. I'm grateful. So have a good night rest and enjoy your weekend. Bye.